So in this video, we are going to talk about radical equations. And radical equations just means it's an equation that contains a radical. So in the past, we've seen examples that look like this. If we had the square root of x equals 4 and we wanted to solve it, we would undo the square root by squaring on both sides, and we would get x equals 16. The same thing would be true if you had a cube root. Say I had the cube root of x equals 2. If I wanted to undo the cube root, then I would cube it. And when you cube both sides, you would get x equals 8. Same would be true with fourth roots, fifth roots, etc. In this lesson, we're just going to concentrate on square roots. So to undo a square root, you square both sides of the equation because that's just the opposite operation for a square root. Before you square both sides of the equation, though, you want to make sure you isolate the radical to one side. So actually, let's just write this down. So to solve, we are going to isolate the radical, and as much as you can. So if possible, you want the radical all alone on one side of the equation. Then you do opposite operations, which in this case is going to be square both sides. And when we square both sides, we're going to eliminate the radical. And then you're going to solve the polynomial that's left in any way, and then you want to check your solution. And this is a pretty important point in these types of problems because when you square both sides of the equation, it's possible that you actually introduce a solution that doesn't actually work in the original problem. So you need to be able to check your equations. All right, so let's do a few examples. Say we have the square root of x plus 25 equals 4. Just as a reminder, the square root here, this x plus 25, you cannot break that up into the square root of x plus the square root of 25. It just doesn't work that way. And you can test that with some numbers that you know. If you want, put in your calculator and see if it works. And it does not. The example that I usually give is like the square root of 9 plus 25 is not equal to the square root of 9 plus the square root of 25, because the square root of 9 is 3 and the square root of 25 is 5, but 9 plus 25 is 34, and the square root of 34 is not 8. So that doesn't work. All right, back to our original problem. Okay, so we're going to try and solve it. So we need to, first, is our radical isolated? Yes, it is. It's the only thing on this side of the equation, and it's equal to 4, so we are going to square both sides. When we do that, the radical is eliminated, so we have x plus 25 equals 4 squared, which is 16. And then we just go ahead and solve it by using opposite operations. We subtract 25 from both sides, and we end up with x equals 9. Then we do, negative 9. Then we do a quick little check. Negative 9 plus 25 equals 4. Is that true? Yes, it is, because this becomes the square root of 16 equals 4, and the square root of 16 is 4. So that works. Great. So we were correct. Our answer is x equals negative 9. All right, let's do another one. Say we have the square root of 5x minus 9 equals 11. The radical is already isolated. Awesome. So in order to start, we're going to square both sides. Once we do that, the radical is eliminated. So we have 5x minus 9 equals 121. Then we just solve the equation like normal. So we'll add 9 to both sides. We end up with 130, and then divide by 5 on both sides, and you end up with 26. Then do a quick little check. 5 times 26 minus 9, does that equal 11? And it does. So we're good. Cool. All right, so those are basically simple because you didn't have to do anything. If by chance you had a value in addition to the radical, something like this, 8 root 10x minus 7 equals 9. Make note that the 7 is not under the radical, and neither is this 8. So the first steps we want to do is we want to isolate this radical as much as possible. So we're going to add 7, and we have 8 root 10x equals 16. Then we're going to divide by 8. So we have root 10x equals 2. And now we can square both sides. And we would eliminate the radical by doing that, and then you get 4. And then we divide by 10 on both sides, you would get 4 over 10, and then simplify to get 2 over 5. This would be our final answer. Okay? All right, so those are relatively simple because they are just radicals, and you only had to do like 1 or 2 things in order to solve them. So let's look at a little bit more complicated. What if we have variables on both sides? So say, for example, we have x plus 1 equals the square root of 7x plus 15. Now, in this case, the radical is totally isolated, so we're going to go ahead and square both sides. But when you square both sides, recall that you are squaring a binomial on the left here. And when you square a binomial, you have to use FOIL. Do not write down x squared plus 1. That is wrong. You must FOIL it, x plus 1 times x plus 1. You can use your little shortcuts, or you can actually FOIL it out, but you get x squared plus 2x plus 1 equals 7x plus 15. So we eliminated the radical. Okay, now, little alarm bells should be telling you this is a quadratic because there's an x squared. And in order to solve a quadratic, I'm either going to use the quadratic formula, or I'm going to factor, or I'm going to square root both sides, which I can't because this has a linear term, or I'm going to complete the square, but yuck, who does that? So but all of those things we need to get it into standard form. So we're going to subtract 7x. And subtract the 15. So we're just moving everything to the left-hand side. So we get x squared minus 5x minus 14 equals 0. So here is our trinomial, our quadratic, and we can solve it either by factoring or using the quadratic formula. This one is easily factorable. X minus 7, x plus 2. All of that is equal to 0. We use our zero product property to say x minus 7 equals 0 or x plus 2 equals 0, which means x is equal to 7 or negative 2. And again, now we're going to go check those solutions. So 7 plus 1 equals the square root of 7 times 7 plus 15. So that would be 8 equals 49 plus 15, square root of 49 plus 15. So we get 8 equals the square root of 64. Yes, it does. So that one works. Let's try negative 2. Negative 2 plus 1 equals the square root of 7 times negative 2 plus 15. So we get negative 1 on this side, and then we get the square root of 1 on this side. But the square root of 1 is 1, so this does not work. So that means that actually our results do not include negative 2. So our only solution should be 7. Okay? Awesome. So that's pretty much it. When you're solving a radical, you want to isolate everything as much as possible. Isolate the radical as much as possible, and then you'll square both sides. And then it's just arithmetic and algebra after that. Thanks.